Hi everyone. So in this video we are going to see the concept of oscillators. So before starting it, let's just go to this slide, which is amplifier versus oscillators. So what is the difference between amplifiers and oscillators? So let's just see this. So amplifiers we have studied. Using MOS we have designed amplifiers. So what we did with there, first we gave that a DC bias, then we applied a small signal input and we received some output. Say yes or no. We gave a DC bias, we applied some small signal input and we received some amplified output. So what this circuit was doing, it was giving you an amplified output using this DC bias. First, using this DC bias, it was setting its operating point. Using this DC bias, it was setting its DC operating point. After that, it was giving you an amplified output with respect to the applied small signal input. So this was your amplifier. Now in oscillators, what do? You do not apply any input. The applied input is zero. Without even applying some input, you get some oscillatory output. You just give a DC bias. In this DC bias, there would be some noise component present, right? In this DC bias, there would be some noise component present. Some noise will be present. Now we will connect this particular circuitry in a certain manner. What that manner would be, we will see it. We will see that manner. But we will connect this particular circuitry in a manner that your output is oscillatory without even applying any input. You did not even apply any input, still you are getting some oscillatory output. Are you getting this point? So what is the difference between an amplifier and oscillator? This can be a good interview question. In case of amplifier, there is a DC supply which sets the DC operating point, then we apply a small signal input and receive a amplified small signal output. Also we can receive a DC output as well. But in case of oscillators, we only have DC supply. Based on that DC supply, we get a oscillatory output. Output is oscillatory, not stable. Here we will get a stable output, but here the output will be oscillatory. Output can keep on oscillating, and how it will oscillate, we don't even know. It can keep on increasing like this as well, or it may happen that it keeps on decreasing like this. It keeps on decreasing like this, or it may happen that it remains sustained. Sustained means the oscillations remain same. So anything can be there at this output. But here what will happen? Here it will simply be the amplifier gain into V, if the amplifier gain is A. That's it. So V0 would be simply whatever the input you applied multiplied with the factor of A. That's it. But in case of oscillator, you don't know what will be the output. It will depend on this circuitry. Whatever is there in this block, your output will depend on that. So let's see let's understand the concept of oscillations now. So let's just say this is a particular amplifier A is given. You apply some input to it and you receive some output. What that output would be? That output would be some A into V, or some output X you are getting. I am saying some output X you are getting. You are getting some output. Now what you do? You connect a feedback. You connect a feedback and nullify the input. You connect a feedback and nullify the input. This input is gone. So what is your current output? That is X. Now X will be multiplied with beta X. Since these both are positive, so this beta X will go here. And what is the next output you are getting? That is A beta X. Now this A beta X will go here, and this A beta X will be multiplied with beta. A beta X will be multiplied with beta, right? And the same thing will come here. A beta X is being multiplied with beta is coming here. Now that will be multiplied with A. So what you will get? A beta square X. Now this A beta square X will go and come back. What it will be? A beta cube X. And finally what you will get? Your output will be A beta to the power n X. Say yes or no. What did you do? You applied some input, you got some output, that is X. Now that X is being fed back to the feedback factor. It is fed back to the feedback. Then what you were receiving? You were receiving beta X. Then it was multiplied with A. So you got A beta X. Then it went back in the loop. The loop gain is A beta. Right? The loop gain is A beta. Well, actually the loop gain is minus A beta, because what is the concept of loop gain? We studied it in feedback amplifiers. Minus Vf by V test. So always put the negative sign. So forget about the loop gain, but here what you understand is that in this loop you get a gain of A beta, right? In this loop you get a gain of A beta. Then again you get output that is being fed back to the input. Again you are getting A beta, A beta, A beta. So like that, this is your output. Say yes or no. So here I gave you the input and you received some output. But sir, like few minutes back you said that there is no input in case of oscillations, right? There is no input in case of oscillations. Yeah. So that's why I did not write output to be AV. I just write it output to be X. So what do I mean by that? Like this output can come from anywhere. This was just an analogy to to feel it that output is coming from the input. Output can come from anywhere. Output can come from the noise present in the circuit. Whatever the noise is there, based on that noise as well, the output can come. Somehow you got some output. That's it. This is what I wanted to tell. You got some output. V0 equals to X. You got some output somehow without even applying the input. You did not even apply the input. Because of the noise present in the supply or anywhere in the circuit, you got some output. Now you connected a positive feedback. Sorry, you just connected a feedback. Why it is positive, that we will see. You just connected a feedback. Now that will be multiplied with the factor of beta. So X into beta, that will be then multiplied with the gain A. So A beta into X you will get. Then again it will flow in the loop. So A beta square X you will get. Then A beta cube X you will get. So in that manner you will get your output. So basically I can write, what I can write is, your output is A beta to the power n x. Eventually this will be your output, right? So let's just remove it. Just write the first one. This will be beta x, this will be x. So this will be beta x. So beta x multiplied with a beta x. So this will be your output, right? Now let's just see the different cases. First we will take, if a beta is lesser than 1, then what will be your output? A beta is lesser than 1. So let a beta is 0.5. So your output will be 0.5 to the power n x, right? 0.5 to the power n x. So after the first cycle, what you will get? 0.5x, right? How you will get? First you will get 0.5x, then you will get 0.5 square x, right? Then you will get 0.5 cube x, and so on. This is how it will go, right? In this manner it will go. So let's just say this was your 0.5, this was your 0.5x. In the next cycle, the output is decreasing or increasing. Initially it was x by 2. Now what is that? X by 4. 1 by 2 to the power square, x by 4. Then 1 by 2 to the power cube, x by 8. So output is continuously decreasing. So what will happen here? Here the first you will have some oscillations, but since the output is continuously decreasing, eventually this oscillation will die out. Eventually these oscillations will die out. At the steady state, oscillations will die out. You started with the oscillations. The output was oscillatory. First you got some oscillatory output. Because of the feedback, the oscillations were there, but slowly it died down. Because your A beta was less than 1. Now let's take the case for A beta greater than 1. Case 2. A beta greater than 1. So let A beta equals to 2. A beta is equals to 2. So what will be your output? 2 to the power nx. So basically it will start from 2x, then 4x, 8x. In this manner your output will keep on increasing, right? So your output will just keep on increasing here. Let's just say it started like this, but the oscillations will keep on. The oscillation will be sinusoid or cosinusoid, or some random oscillations will be there. We don't know. but the oscillations will increase. That's what we know. Just to show it in a better manner, I made it sinusoid. It can be any random oscillations it can be, but oscillations will increase, that's for sure. If A beta is greater than 1, the oscillations will increase. If A beta is lesser than 1, the oscillations will eventually die out. So we started like this, but it will keep on increasing, right? So what do you understand? Here also the oscillations are not sustained. What I am using the word sustained. Sustained. Sustained means oscillations should be constant. Here also oscillations are increasing. At steady state, there will be very high oscillations, which you don't want. You don't want that much of high output, right? So oscillations are not sustained here as well. So what do you need for a sustained oscillation? Tell me, think about it. For sustained oscillations, A beta should be equals to 1, right? If your A beta is equals to 1, what will happen? So case 3, what is the case 3? Case 3 is that if your A beta is equals to 1, so if your A beta is constant to 1, then what will be your output? Your output will always be X, right? Output will always be X. Because what was your output? Output was A beta to the power nx. Here basically you will get X. Then A beta is 1, X. A beta is 1, X. A beta is 1, X. Always it will be X. So there will be constant oscillations. The oscillations will be constant. So here you can see that. So whatever the oscillations you started with, it can be anything. It need not necessary to be sinusoid. It can be anything. Oscillations are sinusoid. Oscillations are sustained. Here you are getting sustained oscillations. Right? Because you are always getting a constant output that was X. After the loop, you had a constant output that was X. So for sustained oscillations, your A beta should be equals to 1, not greater than or equals to 1. For sustained oscillations, your A beta should be equals to 1. And if they are saying that for oscillations, what should be the condition? For oscillations, A beta should be greater than 1. Because if A beta is greater than 1, then oscillations are there. At steady state, oscillations are there, but these are of very high amplitude. Here, at steady state, oscillations are not even there. If A beta is lesser than 1, at steady state, oscillations will die out. But here, the oscillations are not dying out, at least. At least oscillations are there. It is not dying out. But here, the oscillations are sustained. It is constant. This is the one thing that A beta should be equals to 1, or we should write mode of A beta should be equals to 1. Mode of A beta we are talking about. No, here I will write A beta should be greater than 1. In the next slide I will write mode of A beta should be greater than 1. Why I am making mode here? Because the thing is, in this loop I don't want any phase shift. Like I don't want that my A is providing me some 180-degree phase shift. I don't want this thing. If A is providing me 180-degree phase shift, then I would want that B is also providing me 180-degree phase shift. I hope you know what do you mean by 180-degree phase shift. This is 0-degree phase shift. This is how much phase shift? 90-degree. This is how much phase shift? 180-degree. And this is how much phase shift? 270-degree. This is again 360-degree. 0-degree phase shift. Now this was 90. 90 plus 360, whatever it is, 450, right? And then 540 or 180. So I want only 0-degree phase shift. In this loop, I don't want any phase shift. Why is that so? Let's just say in this loop I am getting 180-degree phase shift. Let's just assume. Let's just assume this A is giving me a phase shift. So what do you understand by that? If you are having a signal Y here, what you will get at the output? Minus AY, right? If it is providing you 180-degree phase shift, what does that mean? There will be a negative sign. That's it. Are you understanding this point? If it is providing 180 degree phase shift, what does that mean? That there will be a negative sign, right? So here you are having x. X will be multiplied with beta. It will be beta x. Beta x will be multiplied with a but 180 degree phase shift. So what you will have at the output? Minus a beta x. In the next cycle, what will happen? Minus a beta x will go here. It will be multiplied with beta. Now this will be multiplied with again minus a. So in the next cycle, you will have a beta square x. And then again you will go, again it will be multiplied with minus a. So in the next cycle, you will have minus a beta qx. Now even if your a beta is equals to 1, a beta is equals to 1. So what you will have? X. First, in the first cycle, you are having minus x. In the second cycle, you are having x. Then again you are having minus x. Then again you will have x minus x. The oscillations are not constant. Let's just say you started with this. Then in the next cycle, you will have this. Right? Then again there is minus. Then again you will have this. So these oscillations are not sustained. You wanted a sustained oscillation. So that's why between input and output, you need 0 degree phase shift. Okay? You just need a 0 degree phase shift. Between input and output, I shouldn't say. In the loop, you need 0 degree phase shift. So in the feedback loop, there should be 0 degree phase shift. And what do you mean by 0 degree phase shift? Positive feedback. Do you remember it? I told you one thing. In negative feedback, there is 180 degree phase shift. Because in negative feedback, what happens? If this node increases, then eventually this node decreases, right? If your output node increases, then you walk back in the loop and eventually your output node would decrease. That means there is 180 degree phase shift in negative feedback. But in positive feedback, there is 0 degree phase shift. So here I am saying that you need 0 degree phase shift or 360 degree or 720 or 1080. If you need 0 degree phase shift, that means you need to connect it in the, so whatever the amplifier you are having, you need to connect that particular amplifier in positive feedback to get a 0 degree phase shift. So that's why for getting an oscillatory output, for getting an oscillatory output, first thing is that your a beta, mode of a beta, your loop gain, mode of loop gain should be equals to 1 and there should be 0 degree phase shift in the loop. Say yes or no. So these 2 points are known as Barkhausen criteria. So he was the first guy to prove it. We are just understanding his theory, nothing else. We are not proving it. After his statement, after his paper, now we are understanding his theory. So what is that thing? For sustained oscillations, you need your a beta to be 1. Your loop gain should be equals to 1. The magnitude of loop gain should be 1. So here in the bracket, I am going to write magnitude of the loop gain should be equals to 1. Magnitude of the loop gain should be equals to 1. And the phase shift provided in the loop, phase shift around the feedback loop must be 0, must be equal to 0 or the multiple of 2 pi or multiple of 2 pi. The phase shift around the feedback loop must be 0 or multiple of 2 pi. Are you able to understand this point or not? This is the most important point of this whole lecture. After that, there is just calculation, nothing else. Just the calculation. First, we are going to solve some questions. After that, we will see some standard circuits. That's it. So whole complete theory will be there. That's it, nothing else. So we started with this thing. First, we started with the difference between amplifiers and the oscillators, right? Then we started with the, so that let's just say you are getting some x output, then you connect a feedback, then what you will get? A beta x output, a beta square x output. So eventually your output is a beta to the power nx, right? If your a beta is less than 1, then your oscillations will die out. If a beta is greater than 1, then oscillations will be sustained. Sorry, the oscillations will be there, but they are not sustained because the amplitude is rising. If a beta is equals to 1, then your oscillations are sustained. But there is one more condition, that there should not be any phase shift. The phase shift provided in the loop should be 0. We understood it with the example of phase shift provided 180 degree by the gain A. If A is providing you 180 degree phase shift, what does that mean? That means you will have x output, then minus x, then again x, then minus x, x minus x. So your output is not a sustained oscillation there. So this was the Barkhausen criteria. Even if you didn't understand the conditions, there is no issue. You can remember the conditions. What are the 2 conditions? That your loop gain, magnitude of loop gain should be equals to 1 and the phase shift provided in the loop should be equals to 0. That's it. This is the only conclusion which you need to remember. This is the most important part. Till now, even if you don't understand anything, there is no issue about it. This is the only conclusion you need to remember, that for sustained oscillations, your loop gain, magnitude of loop gain should be equal to 1, and the phase shift provided by the feedback loop should be equal to 0, 180 degree, 0, 360 degree, 720, or the multiple of 2 pi. That's it. Let's see the first question. This is the question given in front of you, right? So they are asking, for sustained oscillation, what should be the sign of A and B? This is the first question. And then the second question, for sustained oscillation, what will be the frequency of oscillations? So these three op-amps are given, and frequency, and they are providing you a gain of h of s. Each op-amp is providing you a gain of h of s, and this is the transfer function is given. Let's just say if there was x input and this was y output, so your y would have been h of s into a. This is what they are saying. There is no input in this particular circuit. So what do you understand? From here to here, there is a forward gain, and from here to here, this is a feedback. Say yes or no. This is the feedback, and this is the forward gain. We made this block diagram, no? This was the block diagram. And there will be a forward gain, then there will be this output. Some part of output will be fed back to the input, but making sure that there should be 0 degree phase shift. So this is our target, that we will make sure that there will be 0 degree phase shift in the loop and there is no input. So first tell me, what is the value of A? For the value of A, in any particular circuit, you will find one thing. First is the thing from where you are starting your circuit. I am saying that I am starting my circuit from here. This particular node is this node. This particular node is this node. So from here to here, I am getting a forward gain, right? And then in this feedback path, there is one gain. What is the gain in the feedback path? What is the value of beta here? Can you tell me what is the value of beta here? Here, what is the value of beta? What is the value of beta? Output is directly coming to the feedback. Output is directly coming to the feedback. So what is VF? Here VF is equals to V naught. VF is equals to V naught. So what is the value of beta? Beta is 1. That's it. If you have studied the feedback amplifiers, then only you will be able to understand the oscillations. Otherwise, you will not be able to understand. Like, what is VF? Now, don't ask me what is VF, because if you have studied feedback amplifiers, then you know what is VF. VF is beta V naught, right? This is your VF. So here feedback factor is 1. So VF is equals to V naught. So beta is 1 here. What is A? We don't need to think about it. First, what is our question? For sustained oscillation, what will be the sign of A and B? So from in the feedback path, what is the phase shift? In the feedback path, what is the phase shift? Tell me. From here to here, what is the phase shift? 0 degree, because beta is 1 only. Phase shift in the feedback path. Phase shift in feedback path is equals to 0. That means angle of beta is equals to 0 degree. Now, how much phase shift you need in the forward path for sustained oscillations? In the feedback path, you are getting 0 degree phase shift. In the forward path, from here to here, your phase shift is 0 degree. Then how much phase shift you will expect from here to here? 0 degree only, no? Then only there will be sustained oscillations, because you need 0 degree, 360 degree or 720. Both, all are same only. So from feedback path, we are getting 0. So from forward path, you will expect 0 degree phase shift only, no? Say yes or no. So if we are going from here to here, I need 0 degree phase shift. So required, what is required? Required is in the forward path phase shift equals to 0 degree, right? Tell me one thing. from here to here, how much phase shift is there? Or I can write in this manner. From here to here, how much phase shift is there? 0 degree, right? Because if this node increases, then this node will increase, right? Because this is the positive node. Say yes or no. This is the positive node. If this node increases, then this node will increase. So there is 0 degree phase shift. Here you don't know how much phase shift is there. That you need to find. From here to here, how much phase shift is there? 0 degree. Say yes or no. From here to here, how much phase shift is there? 0 degree, because this node increases, then certainly this node will increase. So there is 0 degree phase shift. So how much phase shift is required here? Tell me. In the feedback path, there was 0 degree phase shift. In the forward path, we needed 0 degree phase shift. These two op-amps are giving you how much phase shift? 0 degree phase shift only. So these two op-amps are giving you 0 degree phase shift only. So how much phase shift do you need from this particular op-amp? 0 degree only, no? From this particular op-amp, you need 0 degree phase shift only. 0 degree required, right? So if you need 0 degree phase shift from this op-amp, then what does that mean? That A should be positive and B should be negative. Because if A is positive, then there will be 0 degree phase shift. Because let's just say there is some input, because from the feedback, input is applied here. From feedback, whatever that is coming, that is applied here. So from here to here, it will get 0. From here to here, it will get 0. From here to here, it will get 0. So 0 degree, 0 degree, 0 degree. So A should be positive and B should be negative. So this is the answer of the first question. That your A should be positive and B should be negative. So this was the answer of the first question. Let's answer the second one. What is the value of beta? Beta is 1. What is the value of A? How do you find the value of A? In the forward path, you need to find the gain. In the forward path, you need to find the gain. Forward path gain. So let's just say there is some X input. So what will be the gain here? H of S into X. What will be the gain here? H of S whole square into X. And what will be the gain here? That would be H of S whole cube into X. So what is the forward gain you are getting? Forward gain is, what is A? Forward gain is H of S whole cube. That's it. This is the gain. This was the output and this is the input. So what would be the gain? H of S whole cube. So your forward gain is H of S whole cube. This is the forward gain. This is the feedback. So you can certainly write in this manner that your A is H of S whole cube and your beta is 1. These arrows I am putting it as it is. Okay, these arrows I am putting as it is. This I can remove. This I can remove. This is my forward gain, H of S whole cube. So what I can write? 2 to the power 3 divided by 1 plus S by 10 to the power 6 omega cube, right? What will be the value of A beta? A beta will be the same only. What will be the value of A beta? Yeah. So A beta will be same 8 upon 1 plus S by 10 to the power 6 whole cube, right? Yeah, right. Now I can extend it like A beta would be 8 by 8 by, this would be A plus B whole cube. So that would be A cube plus B cube plus 3A square B plus 3A square B plus 3AB square, right? Well and good. What else you can write? 8 divided by 1 minus j omega cube divided by 10 to the power 6 to the power 3. Say yes or no? This is our A beta. I am not taking any magnitude. I am not taking any gain. I just wrote the A beta equation. A beta S you can write or whatever you can write. Then I am replacing S with j omega now. S with j omega. S with j omega. I am replacing S with j omega. So what will be your j omega cube? That would be minus omega cube, right? Minus j omega cube, sorry. Because j cube is minus j and omega cube will be omega cube. So j omega cube will be, j omega whole cube will be minus j omega cube, right? So minus j omega cube upon 10 to the power 6 to the power 3 minus 3 omega square divided by 10 to the power 6 to the power 2 plus 3j omega to the power 6. Say yes or no, right? Now, what do you need? You need 0 degree phase shift. You need 0 degree phase shift. In A beta, what you need? Angle of A beta should be equals to 0. This is your required thing. If you need 0 degree phase shift, this number has to be real now. Say yes or no. If this number is imaginary, then certainly there is some phase shift, right? A beta has to be real. And if I put this part and this part, what I can write? I can write this one as 8 upon 1 minus 3 omega square 10 to the power 6 to the power 2 plus j 3 omega by 10 to the power 6 minus omega cube divided by 10 to the power 6 whole cube, right? If I put this part equals to 0, then this value will be real. Say yes or no. If I put this part equals to 0, then this value will be real, right or not? So you need angle of A beta should be equals to 0 degree. Then what you do? You will put this one equals to 0. So imaginary part of A beta, I am putting that equals to 0. You must have understood it, right? Because I need 0 degree phase shift. So if I need 0 degree phase shift, I want this A beta to be real. If I want this A beta to be real, then I would put this one equals to 0. Now some people will say, sir, what if you get some omega from there, but what if this value becomes negative? If this particular value becomes negative, then your phase shift would be 180 degrees, right? If this particular value becomes negative, then your phase shift would be 180 degree. But that we will check. Once we put this equals to 0, after the value of omega that we get, we will put that value of omega here. And then we will check if this is negative or this is some positive value. So that we are going to check. So no worries about it. So first let's put the imaginary part equals to 0. So what we will get? Right? No issue about it. So omega would be equals to under root 3 into 10 to the power 6 radian per sec. Right? So now you will notice a very interesting thing. So this is the frequency of oscillations. This is the answer, frequency of oscillations. But this should not be our final answer, right? We need to check what is the A beta value we are getting. What is the A beta value we are getting? So this is what we need to check now. What is the value of A beta? A beta at omega equals to root 3 into 10 to the power 6. What that value will be? The imaginary part will be 0, so I will not write it. 8 divided by 1 minus 3 omega square, 3 into omega square into 3 into 10 to the power 6 square divided by 10 to the power 6. So 10 to the power 6 and 10 to the power 6 will get cancelled. What you are getting? A beta is equals to minus 1. So you expected, like, this was required. The angle of A beta should be equals to 0 degree. So for getting the 0 degree, it is certain that A beta has to be real, right? If you need 0 degree phase shift, that means A beta has to be real. Now if A beta is real, then there are two possibilities. let's just say A beta is equals to 2 and A beta is equals to minus 2. Both are real. So this will give you 0 degree phase shift and this will give you 180 degree phase shift. So first you put this equals to 0. You put imaginary part equals to 0 to get a real number. You get a real number. Then you need to check if the real number is giving you 180 degree phase shift or 0 degree phase shift. Now the real number is giving us 180 degree phase shift. So here A beta is giving us 180 degree phase shift. So where did we go? Where did we go wrong? Tell me one thing. Where did we go wrong? So in the first one, if I had put A is equals to negative and B is equals to positive, if I had put A is equals to negative and B is equals to positive, then what would have happened? So here we will have a negative sign, right? Here we will have a negative sign because from here to here the gain would have been h of s into x. Now there is a negative sign, like this is negative and this is 0. So what will be the gain here? H of s minus h of s into h of s. So minus h of s square into x. Are you getting this point or not? What I mean to say is that this is h of s into x. Why it is h of s into x? Because this is 0, this is x. So what is the gain of OpAmp? H of s into V positive potential, that is x, V negative potential, that is 0. So x into h of s. Now this input is fed to this one. If A is negative, then what will be the next gain? If A is negative, then what will be the gain? Positive potential, that is 0. The negative potential, that is x into h of s into x into h of s, sorry, h of s, that is the transfer function. So your output would have been minus x into h of s square. So this is what I have written. So here, if A would have been negative and B, if A would have been negative and B would have been positive, if A would have been negative and B would have been positive, then here the negative sign would come. If the negative sign would come, then it would also be negative. 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 Then you would put that equals to 0. Then this would also be negative. And here you would have been getting 1. And your phase shift would be 0 degree. So just by observing the circuit, when we saw this circuit, what it felt like? It felt like that from here to here it is 0 degree. From here to here it is also 0 degree. So from here to here, if I put A equals to positive and B equals to negative, I will get 0 degree phase shift. But I did not think of this particular transfer function. You have to think of this transfer function as well. So by just watching the circuit, by just seeing the circuit, saying that A should be positive and B should be negative, that is absolutely wrong. So we should not go with this approach. Okay, this was one of the finest question, like one of the best question of oscillators. So I hope it must have cleared a lot of concept. So always, never by looking at the circuit, you should never write that A should be positive or B should be negative. Nothing like that. First you need to find the total transfer function. So h of s cube, this was the forward gain, this was the forward gain, minus h of, like, how would you would have solved it? You would have solved it like, what is the forward gain? You would have written h of s cube is my forward gain. Then you would get to know that you need a negative sign. Here you would understand that you need a negative sign. So for getting that negative sign, your A should be negative and B should be positive, right? So in the end, I got to know that my A should be negative and B should be positive. Say yes or no, right? Understood? So this was the question, which was very, very good question. It was an excellent question. So we will solve more question. It will be more clear to you. Let's answer this one. So what do you think? What is the forward path? From here I am starting. So this is my forward path, right? This is the forward path. And what do you think? What is the feedback path? What is the feedback path? From here to, this is your V0. V0 will be carried here. From here to here. This is your feedback path. How much phase shift is there? 180 degree. How much phase shift you require? 180 degree required. 180 degree required. Do you remember when you get 180 degree phase shift? If you put A equals to positive and B equals to negative, that's it. If you put A equals to negative and B equals to positive, how much phase shift you get? 0 degree. Because we have solved this particular question. In that, it is the same question, but here there was no inverter connected. Yeah, like some people would not have understood from here to here why there is 180 degree phase shift. Because this is an inverting amplifier. if you have applied some input V in here, what you would have got here? Some minus A V in, no? This is an inverting amplifier. This is an inverting amplifier. What do you mean by inverting amplifier? Inverting amplifier will always give a 180 degree phase shift, right? Understood? If you applied V in input here, what you would have got here? Minus V in. So that means there is 180 degree phase shift. So an inverting amplifier always gives 180 degree phase shift. So in the feedback path, you are having 180 degree phase shift. So in the forward path, you would require another 180 degree phase shift. Say yes or no. And in the previous question, we got to know that if A is negative and B is positive, then we get 0 degree phase shift. So for getting 180 degree phase shift, what you will do? You will put A equals to positive and B equals to negative. Say yes or no. For getting 180 degree phase shift, here we got to know that for getting 0 degree phase shift, A should be negative and B should be positive. So what should be the case here? It should be the otherwise. That's it, because we also checked for A equals to positive and B equals to negative. When we were checking A equals to positive and B equals to negative, here this negative sign was not there, and since we were getting -1. So if we are getting -1, that means we are getting 180 degree phase shift. So from the feedback path, we are getting 180 degree phase shift, and in the forward path, in feedback path, we are getting 180 degree phase shift, and also in the forward path, we are getting 180 degree phase shift. So total 360 degree phase shift is there. Did you understand this? If not, then let's solve one more problem. You will certainly understand it. So hold on to till the end. You will certainly get to understand a lot of new things, or whatever that you are not able to understand, that you are going to understand. So here, this is our output. So tell me, what will be the feedback? From here to here, it will be the feedback. This will be the feedback. Now this VF will go here, and this will be the forward gain. From here to here, this will be the forward gain. Can you tell me, or you can make it in this manner as well? From here to here, this will be the forward gain. This is the feedback, and this will be the forward gain. Can you tell me how much phase shift is there in the forward path? In the forward path, how much phase shift is there? Here, find the frequency of sustained oscillation, and you need to find the ratio of RF by R for sustained oscillations. Okay, two questions are there. So in the forward path, what is the forward path? This is the forward path. Forward path, and this is feedback. You could have started from here. This is my forward gain, and then this is the feedback. So in the forward path, how much phase shift is there? 0 or 180? 0 degree, because this is a non-inverting amplifier, right? Your V0 is Vf into 1 plus Rf by R. Forward path is a non-inverting amplifier. Forward path is non-inverting amplifier. So A is equals to 1 plus Rf by R. This is the forward gain. And what is the angle? Angle provided is 0 degree. Now what about the feedback now? What about the feedback? So what you need to find? You need to find VFS by V0S. So what I can do is that I can simply copy this circuit and paste it here. This is your V0S, this is your V0S, and this is your VFS, right? Everything is crystal clear. This is your V0S, this is your VFS. What will be your feedback? What will be your feedback factor? This was your V0S, and it was fed back to the input side, VFS. So CR, RC. At output capacitor C, you are having VFS. Output capacitor C, you are having VFS. What is your feedback factor? Beta. That would be VFS by V0. Sorry. What is your V0S? What is your VFS? VFS is beta V0S. What will be the feedback factor? Feedback factor would be VFS by V0S. This would be the feedback factor. So your target is to find VFS by V0S. So first target is to find VFS by V0S. So let's try finding VFS by V0S. So what that would be? What I can do? I will apply Thevenin's theorem here. So I will replace this circuit with a single voltage source and a single resistance. So how I can replace this circuit with a single voltage source? So what will be the voltage coming here? I am applying Thevenin's theorem. So what will be the voltage? That would be RCS upon RCS plus 1 into V naught S. That would be the voltage. And what will be the impedance? Now you cannot say that this voltage will be coming and that would be fed to RC. No. You need to write the impedance as well. You will short circuit the input and you will see the impedance. How I am writing the potential here? That is R upon R plus 1 by CS. Because Thevenin voltage is open circuit potential. Thevenin voltage is open circuit voltage. So R upon R plus 1 upon CS. So RCS upon RCS plus 1 into V naught S. So that is my Thevenin voltage. That is my VTH. And what is my RTH? For RTH, I will short circuit the input and we'll see from here. So RTH will be R parallel 1 by CS. That would be R parallel 1 by CS. So it would be R into 1 by CS upon R plus 1 by CS. So it would be R upon RCS plus 1. So it would be R upon RCS plus 1. R upon RCS plus 1. And that is in series with R divided by C. And this is your VFS. So your VFS is equals to 1 upon CS upon 1 upon CS plus R upon RCS plus 1. Right? 1 upon CS plus R. I can write it as RCS plus 1 divided by R. Yes or no? R plus 1 by CS. It was R plus 1 by CS. Sorry, R plus. So RCS plus 1 divided by CS. Divided by CS. So what do you think what you will get here? And into V naught S. 1 upon CS upon 1 upon CS plus R upon RCS into this potential. This potential is RCS upon, by any mean you need to find V naught S, VFS by V naught S. You can apply by nodal analysis, by any means you need to find. So this is the way I am finding it. RCS upon, till now you should be comfortable with network analysis because we are about to complete analog electronics. So till now you should be comfortable with all these kind of analysis. If you are not, then you are certainly doing something wrong. 1 upon, at the upper side RCS will be left and at the lower side you will have 1 plus the lower side you will have 3 RCS plus RCS whole square. This is your VFS by V naught S. Am I right or not? Let me check. 1 plus RCS plus square plus 2 RCS, 3 RCS, it would be RCS, it would be RCS plus 1 RCS plus 1. You can cancel, RCS will come here. Yeah. So this is my VFS by V naught S. So what is my feedback factor beta? That is, I will put S equals to J omega. So J omega RC upon 1 plus 3J omega RC. 1 plus 3J omega RC. 1 plus 3J omega RC minus omega square R square C square. Say yes or no. Right? Minus omega square R square C square. Or I can write J omega RC upon, just a second, just one sec. Imaginary part of beta. Yeah, I can write it in this one. Yeah. 1 upon 1 minus omega square R square C square plus 3J omega RC. From forward path, I am getting 0 degree phase shift. From feedback path, how much phase shift is required? Beta equals to 0 degree is required. This is required. For that, beta has to be real. For this, beta has to be real. Beta has to be real. For making it real, what I need to do? What do you think? If I put this equals to 0, if I put this equals to 0, if 1 minus omega square r square c square goes to 0, if this goes to 0, then what you will have? J omega rc upon 3 j omega rc. So it will be cancelled, 1 by 3 you will get, which is absolutely real, and phase shift will be 0 degree, right? Even if you require 0 degree phase shift or 180 degree phase shift, your target should be to make this one real. Your target should be to make this one real. If you require some 90 degree phase shift, then what will be the target? To make it imaginary. If you require some 90 degree phase shift, so your target would be to make this beta to be imaginary. Say yes or no? But that condition will not even come. How will you introduce 90 degree phase shift? I need to think. Okay. Can I introduce 270 degree phase shift somehow? Because if I introduce 270 degree phase shift in the forward path, then in the feedback path I would need 90 degree phase shift. But how I can reduce 270 degree phase shift in the forward path? If anyone has some idea, then they can tell me. But it is not possible to introduce 270 degree phase shift in the feedback path, right? When we study about phase margin, gain margin, we will study more on this. Okay. Anish has taught control system, so there he must have taught all those things, that how much phase shift you can produce, how much you cannot produce. So if anyone can think of any idea like how to produce 270 degree phase shift in the forward path, because like linear amplifiers can only produce like 180 degree phase shift or 0 degree phase shift, linear amplifiers. But if there are some harmonics present in the circuit, some second order harmonics or third order harmonics, then it can be the possible case. So I will think of making a question. I will try making a question. These kind of question will take me around an hour to make. So I will try thinking of that question. Let's come back to this problem. Yeah. So if I put this equals to 0, if I put this equals to 0, then this imaginary j and j will cut and it will be real only. So my target was to make beta to real. If I put omega if this equals to 0, then beta will be real. Beta will be real. So what will be my frequency of oscillation? From here I get the value of omega, that is omega is equals to 1 by RC. So this is my frequency of oscillations. Right, this is my frequency of oscillations. Well and good, no doubt about it. Now I need to check if I put omega equals to 1 by RC, what I will get here. I need to check it. If I put omega equals to 1 by RC, am I getting beta equals to some positive voltage or some negative voltage? Not the voltage, some positive value or some negative value. If I am getting some negative value, that means some issue is there. That means beta will be providing 180 degree phase shift, that I don't want. So I need to check it. So if I check that, what do I get? Beta at omega equals to 1 by RC, that is equals to, this would be 0, so I am not writing it. So this j and j will get cancelled, omega RC will get cancelled, that is 1 by 3. So beta you are getting is 1 by 3. So what does that show? That this is providing 0 degree phase shift, and also A is also providing 0 degree phase shift. So angle condition is satisfied. What is the other condition? That is your mode of A beta should be equals to 1. What does that show? Beta is 1 by 3, so A should be equals to 3. What was your A? A was 1 plus RF by R. A was 1 plus RF by R, and that should be equals to 3. So what is the value of RF you will get? RF should be equals to 2R. So for sustained oscillations, your RF should be equals to 2R. Say yes or no? Right? Your RF should be equals to 2R. For sustained oscillations, RF should be equals to 2R, and this is the frequency of oscillations. Frequency of oscillations, and this is the final answer. How did we solve it? We have a forward gain. The forward gain was from here to here, it was the forward gain. From here to here, you can say forward. This was the forward path. So the gain was 1 plus RF by R, and angle was 0 degree. Now in the from here to here, this was the feedback path. This was the feedback path. So in the feedback path, we need to check how much phase shift is there, how much gain is there, or everything we need to check. Then we got to know like what is our feedback factor beta. By some network analysis, we got to know our feedback factor beta, that was this one. we needed 0 degree phase shift in the feedback path, because in the forward path there was 0 degree phase shift. So for that I need to make my beta to be real. If my beta is imaginary, that means certainly 0 degree phase shift cannot be there. So to make my beta real, I put 1 minus omega square r square c square equals to 0. Then omega goes to 1 by rc I got. Then I need to check at omega goes to 1 by rc if my beta is providing me 0 degree phase shift or not. Then I checked at omega goes to 1 by rc, my beta is providing me 0 degree phase shift. That shows that, what does that show? That shows that it is satisfying the angle condition. And for the gain condition, the gain should be equals to 1. If my beta is 1 by 3, that means my gain A should be equals to 3. If beta is 1 by 3, the gain A should be equals to 3. That means, what is the forward gain A? That is 1 plus Rf by R. That means Rf should be equals to 2R. That's it. So this was our complete analysis. Now those circuits we saw, these are not any standard circuit. This is not any standard circuit. This is just the circuit we made. That's it. These are not any standard circuit. Okay. This was very interesting. Actually, I also thought that A should be positive and B should be negative. But later on, when we derived it, we got to know that A should not be positive. A should be negative, B should be positive. Right. So this is the correct answer. Yeah. So this is the concept of oscillation we studied. Now there are some certain circuit. This is a standard circuit. This circuit is known as Wein bridge oscillator. So this is a standard circuit. So now we will study these standard circuits. Since you have analyzed these kind of circuits, it will be very, very easy to analyze these circuits. What do you think? How will you analyze the circuit? This is the Wein bridge oscillator. So what do you think? What is the forward gain? If I start from here, this is my forward path, right? Forward. And what will be the feedback? Feedback will be coming from here to here. This will be the feedback. Which one is forward? Which one is feedback? For forward, I will write, this is the forward. You started from here, you reached here, and then in the feedback, this is the feedback path. Right? So this node will be your VFS. So what do you think? What is your forward gain? What is your forward gain? This node is your VFS. What is your forward gain? Forward gain is 1 plus Rf by R. 1 plus Rf by R. And what is the angle provided by the forward gain? That is 0 degree. Say yes or no. Right? Angle provided by the forward gain is 0 degree, because this is a non-inverting amplifier. Non-inverting amplifier. So the angle provided by the phase shift by the forward gain is 0 degree. So from the feedback as well, you will need 0 degree. But let's just find your feedback factor first. So we are going to find feedback factor. So what that would be? VFS would be, what this parallel combination will give you? R2 parallel with C2. What it will give you? R2 upon R2 C2S plus 1. Right? So VFS would be simply R2 upon R2 C2S plus 1 divided by R2 upon R2 C2S plus 1 plus R1 C1S plus 1 divided by C1S. What it was? Actually, it was this impedance divided by this impedance plus this impedance, R1 plus 1 by C1S. So what this would be? R1 C1S plus 1 divided by C1S. So here I am writing R1 C1S plus 1 divided by C1S. So yes or no? Everything is crystal clear. This is your VFS. Right? So what you will get? R2 C1S divided by R1 C1S, no, sorry, R2 C1S plus R1 R2 C1 C2S square plus R2 C2S. I hope I am not missing anything. R2 C1S, okay. R1 R2 C1 C2S square, okay. R2 C2S, okay. R1 C1S also I will get R1 C1S plus 1. plus 1. Basically into V naught s, certainly into V naught s. This I cannot forget. So your beta is, I can replace this as j omega. So j omega R2 C1, j omega R2 C1 divided by, this would be some negative like s square will be replaced with minus omega square. So it would be minus omega square R1 R2 C1 C2 plus j omega will be outside. Here you will get R2 C1 plus R2 C2 plus R1 C1 and plus 1. Say yes or no. Now you need 0 degree phase shift. What do you need? Beta equals to, from beta you need 0 degree phase shift. This is required. This is required. That means beta has to be real. Beta has to be real. Beta has to be real. So for making beta equals to real, what you will do? Let's just put this one ahead. 1 minus omega square r square c square. This would be 1 minus omega square r square c square. So if I put this equals to 0, if I put this equals to 0, this value equals to 0, then what will happen? This j omega and j omega will eventually get cancelled and beta will be real only. So you need to put this equals to 0, this real part equals to 0. So 1 minus omega square r1 r2 c1 c2 should be equals to 0. So what is the value of omega you get? 1 by root r1 r2 c1 c2. So this is the frequency of oscillations. Frequency of oscillations. Right? Just the same thing we are doing, nothing else. But first we need to check at omega equals to this particular value. What is the value of beta? So beta at omega equals to 1 by root r1 r2 c1 c2. What is that value we will get? So this basically, this will be gone. So this is the value of beta we will get, r2 c1 divided by r2 c1 divided by r2 c1 plus r2 c2, r2 c1 plus r2 c2 plus r1 c1. This is what we will get. This is your beta. Or you can, what you can write, beta would be r2 c1 comes downward, so it would be 1 upon 1 plus r2 c1 comes downward, so it would be c2 by c1 plus r1 by r2. This is the value of beta. It is providing you 0 degree phase shift only. This you can directly see because r1 r2 c1 c2 all values will be positive, so beta is providing you 0 degree phase shift. What do you get? This is the value of beta. What we know that our a beta, mod of a beta should be equals to 1, right? This is what we know. This is the beta value we know. This is the value of beta. So what I can write, a should be equals to 1 by beta. What is my a? A is 1 plus rf by r. 1 plus rf by r. So what will be my 1 plus rf by r value? That would be 1 plus c2 by c1 plus r1 by r2. So from here I get to know that my rf by r should be equals to c2 by c1 plus r1 by r2. This is my rf by r ratio, right? This is the feedback factor. This is my rf by r ratio. Say yes or no. rf by r ratio is c2 by c1 plus r1 by r2. Generally people don't remember it. Like generally people remember for this particular case. What is that case? If r1 is equals to r2 is equals to r and c1 is equals to c2 is equals to c, then what will be the frequency of oscillations? That would be root 1 by root r square c square, that would be 1 by rc. The frequency of oscillations will be 1 by rc. And what will be the value of rf by r? Rf by r value will be 2. But you are not going to remember this. What you are going to remember? You are going to remember this formula 1 plus 1 upon, how will you remember it? You remember the feedback path, no? So what is my frequency of oscillations? From here you can write 1 upon root r1 r2 c1 c2. All these parameters, that's it. Okay. Then how will you remember the value of rf by r? So you will write rf by r is equals to, you will start from here, c2 by c1. C2 by, you will start from here and we'll go to this side, C2 by C1. Like, you are not going to do these kind of mistake, no? C2 by R1 plus R2 by C1. These kind of mistake you will not do. Certainly you will not do, because you know, if I am writing C2 at the bottom or in the denominator, I will expect a capacitance only. So these kind of mistakes you are not going to do. So what you just need to start from C2. You are starting from C2. Then you need the other capacitance value, that is C1 only. So you started from C2, you went to C1. Now what is near to C1? That is R1. So R1 divided by R2. So what did you do? You started from C2, you went to C1, then plus R1 divided by R2. This is the method to remember. This is how I remember it. Okay, so like many times people just remember that RF by R should be equals to 2. Because in a lot of questions, what will be given? This thing will be given. In a lot of questions, this will be given. RC. This will be given in a lot of questions. But you don't need to remember it. You shouldn't remember it. You should remember with this condition, that your omega will be 1 upon root R1 R2 C1 C2, right? And this will be your omega. And what will be your forward gain? RF by R. That would be C2 by C1 plus R1 by R2. Say yes or no. Everything is crystal clear? No doubt about it? Okay then. And one more thing, like this particular circuit is the same. This is the same only. This circuit and this circuits are same. Look, check it out. Sometimes this circuit can also be given in the examination. So let's check that out. From output node, C and R series combination is connected. Parallel series combination of C and R is connected to RC. One node is going to ground, the other node is going to the positive path. Parallel combination of one node is going to ground and other node is going to the positive path, right? Negative, this negative terminal, this negative terminal is connected to RF. This negative terminal is connected to RF. The other node of negative terminal is connected to R, and which is going to ground, and this is your output. Similar kind of circuit is there, exactly the same. There is no input here, RC, RF, R. So sometimes it can be shown in this manner as well. So here, if they ask you to find the frequency of oscillation, so what you will do? You will pick these capacitance part. So what will be the frequency of oscillation? 1 by root R into C into C. So it would be 1 by RC only. And what will be the value of RF by R? So you will start from the parallel one. This is the parallel one. You start from here. Let's just say this is C2, this is C1, this is R1, this is R2. So you start from the parallel one, then you go to the other one, plus write the resistance near to the parallel one, divided by write the resistance of the second one. So in the short notes, in one paper, you can write these kind of things which you need to remember, because like in the examination you will have to derive it all. If you don't remember it, if you just remember omega equals to 1 by RC, then you will have to derive it all, because in the examination there is high chance that they will ask this condition. They will give C1, C2, R1, R2 values. That they will not put RC here. They will put R2C or 2CR, and then they will ask you what should be the frequency of oscillations, and also they can ask you what should be the forward gain. So this is how we deal a problem of oscillators. So our target is to see the forward gain. Forward gain is 1 plus R by R. And what is the feedback factor? Here our feedback factor was beta. So first we will find that feedback factor. Then we know in the forward path we are getting 0 degree phase shift. So in the feedback path we need 0 degree phase shift. So for getting 0 degree phase shift, at least our beta should be real. If beta is real, you can have 0 degree phase shift as well. You can have 180 degree phase shift as well. If beta is real, you can get 0 degree phase shift or 180 degree phase shift. So if beta is real, then we will try to make beta real. Then we will check if we are getting 0 degree phase shift or 180 degree phase shift. So here we go to know that we are getting 0 degree phase shift only. So my RF by R value is, then I get the value of beta, from I get the value of A. A will be equals to 1 by beta, so my RF by R value will be C2 by C1 plus R1 by R2. This is my RF by R value. That's it. So this is how we analyze it, and this is the particular case that you can also remember. So this was our first circuit, that was Wein bridge oscillators. Now we are going to study RC phase shift oscillators. So this is the output. This is the output. So certainly this would be the feedback. This is the output. So this would be the feedback. And this is the feedback. So from here to here, this is also output. So from here to here, this is the forward path. And from here to here, this is the feedback path. Right? What is the value of A? A is minus RF by R. What is the angle provided by A? That is 180 degree phase shift. Why so? Because this is an inverting amplifier. This is an inverting amplifier. From here to here, there will be phase shift of 180 degree. So from this path, you require a phase shift of 180 degree phase shift. So now your target is to find VFS by V naught S. So I can make this circuit something like this. This is my V naught S. This is my VFS. Say yes or no. From V naught S, CR is connected to VFS. CR is connected to VFS. So my target is to find VFS by V naught S. Now this will be a very complex calculation. Since this is a standard circuit, so eventually we have to remember the results, because this is a standard circuit. There is 1% chance that it can come into the examination. So we have to remember the result since it is a standard circuit. But I have done the calculation previously only because I don't want to waste your time. Also my time will also be wasted if I do this in front of you. So I will tell you how did I do the calculation, then you can proceed on your own way. Where I have star marked, there only I did some smartness. So my target is to find feedback factor that is beta is equals to VFS by V naught S. This is what I need to find. This is my target. So for that I need to do the calculation. Right? There are 3 CR circuit. So what will be my VFS? VFS in terms of V2S. Like here there is no current basically, so you can write R upon RCS plus 1, R upon R plus 1 upon CS. So RCS plus 1, RCS upon RCS plus 1 into V2S. So from there you get the value of V2S. Then you write down this current. This current is equals to I1 plus I2. So that current would be V2S by R plus VFS by R plus VFS by R, because what is the current here? That is VFS by R, that is equals to I2 only. VFS by R. So VFS by R. From equation 1 you put these values, then you get to this equation, this I value you get. Then what will be your V1S? V1S would be current into this impedance, I1 into 1 by CS plus V2S. Basically, V2S plus this potential will be equals to V1S. So what is that potential? That potential is I into 1 by CS, right? So I1, I value you can put, why I am putting it I1? This is not I1, this is I only, sorry for that. This is I only. So I into 1 by CS plus V2S. So from there you got to know these values, then V0 value you get, then you put the V0 value and V1 value from equation 2 and 3, because in the equation 2 you are having I value and equation 3 you are having V1 value. So that value you put here, then you get V0 is equals to VFS by RCS whole cube in bracket RCS whole cube plus 6 RCS square plus 5 RCS plus 1. This is what you get. So your VFS by V0 S, VFS by V0 S, which is equals to beta, that is equals to RCS cube upon RCS cube, something like that. So basically your beta is this value. Your beta is this value. Now what do you need? You need till this value. If you can remember, you can remember this result, but you don't need to remember this as well. We will see the final results. Those final results only you need to remember. So this is what you have got now, right? Now from beta you need 180 degree phase shift, because from A you are getting 180 degree phase shift already. So from beta you need 180 degree phase shift. This is required. If you need 180 degree phase shift, that means beta again has to be real. Say yes or no. Beta has to be real. Hai na? Why so? Because if beta is real, then there is chance that it can give you 0 degree or 180 degree phase shift. Let's just say beta is 1 by 3 or beta is minus 1 by 3. Both are real. This is giving you 0 degree phase shift and this is giving you 180 degree phase shift. So again beta has to be real. So beta has to be real. This is the conclusion I am getting. Beta has to be real. So if beta has to be real, then what you will do? You will put this equals to 0. So for beta real, you put 1 minus 6 omega square r square c square to be equals to 0. So what is the value of omega you are getting? If you put this equals to 0, then this j will get cancelled out. This j omega all will get cancelled out, right? J all will come out and it will be real only. We can check that. That would be 1 by RC into root 6. This is what you get. Is this the frequency of oscillations? We cannot say. First we need to check if I am getting 180 degree phase shift or not. So beta at omega equals to 1 by RC under root 6. So this is going to be 0, so I am not going to write it. J and J are getting cancelled. So here I am left with omega cube. So what will be my omega cube? So that would be 1 by 6 under root 6. This will be my omega cube. Minus sign is already there. Divided by 1 by r cube c cube into r cube c cube. Divided by minus omega cube. Omega cube, again I am getting this thing. 1 by 6 under root 6. 1 by r cube c cube into r cube c cube. This will go to 0 only, plus 5 j and j is going to get cancelled. 1 by root 6 rc into rc. So what you are getting? Minus 1 by 6 root 6 divided by minus 1 by 6 root 6 plus 5 by root 6, because RC all are getting cancelled. So minus 1 by 6 root 6 divided by minus 1 by 6 root 6 plus 5 by 6. So if you solve it, what you will get? Beta equals to minus 1 by 29. And that shows that beta is equals to minus 1 by 29. What does that show? This shows that angle provided by the beta is 180 degree. So this is what required, and required thing is done. Angle provided by beta is 180 degree and angle provided by A is also 180 degree. So both requirements are done. That means what does that show? That angle provided by A beta is equals to 0 degree. So this beta value, you have to remember that beta value is minus 1 by 29. And what do we know? What is the other thing we know? That your A beta should be equals to 1. That means your mode of A should be equals to 1 by mode of beta. That means mode of A should be equals to 29. What is mode of A? Mode of A is equals to RF by R. That should be equals to 29. So RF should be equals to 29R. So only thing you need to remember is that beta is minus 1 by 29, and the other thing is this is the frequency of oscillations. Frequency of oscillations. So what is our frequency of oscillations here? That is 1 by root 6 into RC. This is what you need to remember. So these things, because this is a very standard circuit, so this you can remember. Okay. Frequency of oscillations. Because this is a standard circuit, that's why I am asking you to remember. Well and good. Everything is crystal clear, no doubt about it. I hope you are getting comfortable in the concept of oscillations, right? So what we studied, we did not see the derivation because I told you this derivation is very big. No one is going to ask you in the examination. So this is the final one. if they are going to ask some good question from this, they will give you the beta value, because they don't expect you to do this calculation in the exam. In a university exam it can be asked, but in like competitive exam it cannot be asked. Even in the interview it will not be asked. In the interview these kind of questions will be asked, that I told you, no? Here we started with like 0 degree phase shift is required, 0 degree phase shift is required. So these kind of questions can be asked in the interview. Like no standard questions they will ask. They will not ask the standard circuits, because everyone remembers the results here. These results everyone remembers. Like these results not everyone remembers. So that's why I told you to remember this one. But here in this one, like this is providing 180 degree phase shift. Here you required 180 degree phase shift. So you find the value of beta, you got this value of beta. Then you go to know that if you need 180 degree phase shift, then certainly your beta has to be real. That's it. Your beta has to be real. So for making the beta equals to real, you need to put this 1 minus 6 omega r square c square equals to 0. So frequency of oscillation is 1 by rc under root 6, right? So this is what you are getting. Then if you put that omega equals to 1 by rc under root 6, then what is the value of beta you are getting? That is minus 1 by 29. So what should be the forward gain? Forward gain should be 29. So Rf by R should be equals to 29. Because what was our forward gain? Here forward gain was not 1 plus Rf by R. Here the forward gain was Rf by R minus Rf by R. This was the forward gain. This was the forward gain minus Rf by R. It was not 1 plus Rf by R. So it was Rf by R. So Rf by R should be equals to 29. So Rf should be equals to 29 R. So these results you need to remember. Omega equals to 1 by root 6 Rc. Some people also write it like omega is equals to 1 by root 2n Rc, root 2n into Rc, where n is the number of CR circuit. Here there are 3 CR circuit, no? So it is 1 by like 1 by root 2n. So put 3. So it would be root 6 into Rc. So this is how also some people remember it, but in the standard circuit you will see only 3 CR circuits, 3 CR circuit, CR, CR and CR. So in the standard one there are 3 only. So either you can directly remember it or you can remember like this as well. 1 by root 2n into Rc. N is equals to number of CR circuits. Okay, so this also you can remember. But in the standard one, if they are asking you anything, that should be 1 by root 2n into Rc. Now there is no formula for beta. Like don't make any formula for beta in terms of n. In terms of n, there is no formula of beta. Okay, this beta is 1 by 29. So yeah, that's it. So the oscillation, like the concept of oscillator is not completed. There are some more standard circuits that we are going to see in the next lecture, and in the next lecture I will come up with some more interesting problems on oscillators. Okay, with that we will conclude our OpAmp chapter. Okay then, thank you. So continuing our oscillator video, so let's see a certain kind of oscillator that is known as LC oscillator. So in this one what will happen is that you will have a inverting amplifier. You will have one inverting amplifier. This particular structure is your inverting amplifier, and then here you will have a LC circuit. The Z1, Z2, Z3 will be made from L and C. So this is your inverting amplifier, and this is your LC circuit, right? So from inverting amplifier, how much phase shift you are getting? From inverting amplifier, you are getting 180 degree phase shift from here to here, right? From here to here, you are getting 180 degree phase shift. So how much do you need from here to here? Another 180 degree, right? This is the forward path, this is the feedback path. So from here to here, you need another 180 degree. This was your forward path, forward, and this was your feedback. Now we will see different kind of oscillator using this particular structure. So there we are not going to derive the expression. There we are not going to derive the expression because the calculation is very complex. So we will avoid the calculation there. We will avoid that derivation there. But I will tell you how to find the frequency of oscillation and how to find the feedback factor. You can find the forward gain, right? What is the forward gain? Let's find the forward gain first. Forward gain. Forward gain A. What is the forward gain? that is minus RF by R. From here to here, the gain is minus RF by R, right? Or you can write mode of A is RF by R. Now you need to find frequency of oscillations, and you need to find what? You need to find feedback factor. So for that, I am not going to bring the calculation part. I will just tell you the method how you will find. That's it. I will just tell the method, nothing else. Okay. So forget about this slide. I will talk about this one later on. But let's talk about this one. So this was your output. From output, some part was being fed to the input. So this is your V naught S and this is your VFS. Do you agree to my point? This is your V naught S. This is my VFS. Now tell me one thing. How much current this ground is driving? 0 ampere current. Say yes or no. This ground is driving 0 ampere current. Do you agree to this point? Now in the ground there is 0 ampere current, so certainly there will be 0 ampere current in this ground as well, because ground is same, right? It's not that one ground is taking up 0 ampere current, so other will take up some 2 ampere current. It's not going to happen. If it is giving 0 ampere current, so like if from the ground 0 ampere current is going out, then from here as well there will be 0 ampere current can be going in, but it would be 0 ampere only. So if positive terminal is driving 0 ampere current, then this will also drive 0 ampere current. Say yes or no. So this current I can say this would be 0 ampere. Now what is this node? This node is 0. This node is 0. So what I can write? Minus VFS divided by Z1S. I am applying nodal. I am applying nodal here. 0 minus VFS divided by Z1S plus 0 minus V naught S divided by Z2S. That would be equals to 0, right? Because this end is driving 0 ampere current. So 0 minus VFS divided by Z1S plus 0 minus V naught S divided by Z2S is equals to 0. So what you are getting as VF by V naught? VFS by V naught S. That is Z1S by Z2S minus, right? So this is your beta, or you can say what is your magnitude of beta? Magnitude of beta will be Z1S divided by Z2S. So you are not going to remember it will be Z1S by Z2S or Z2S by Z1S. You are not going to remember like that. There will be a particular circuitry will be given. Based on that, you will find your feedback factor. Like this Z1 can be inductor, Z2 can be inductor, and Z3 can be capacitor. Or this Z1 can be capacitor, Z2 can be capacitor, and Z3 can be inductor. So these kind of things can be there. So based on that, you will find your beta. Now what you will think? You will say that sir, what was your forward gain? Forward gain was RF by R. And what is your feedback factor? That is Z1S by Z2S. Negative sign is certainly there, that is cancelled. Now what will happen is that Z1 will be some inductor, okay? Z1 will be some inductor. So that would be L1S, let's just say, and Z2S will be some inductor again. So that would be L2S. S and S is getting cancelled. What is your A beta value? RF L1 divided by R into L2. Now some people can have this doubt. Sir, your A beta is purely a resistive value. There is no frequency content. Like in those previous circuits that we have seen, if you have the notes, you can check it out. There are some frequency content, no? Like there is a forward gain in beta, you get some frequency content. Now, how will you find the frequency of oscillations here? How are you going to find the frequency of oscillations? So that's why I told you, no, this is just the method. This is not the complete analysis. This is not the complete derivation. If you need the complete derivation, I will send you a paper which I found on internet that I can send you. There the complete derivation is given, but no one will, like, I don't think in YouTube complete derivation would be available. I will tell you the method as well, how to derive it completely. But this is just an approximated way how to find the value of beta. Just an approximated way. Okay, just I am telling you a way to find the value of beta. Forward gain you can find, and I will tell you how to find the frequency of oscillations. But let's just see this circuitry now. What is this? This is simply this feedback factor only. What did I do? This is your V naught S, this is your V naught S. From V naught S to Z3, is connected, and that is going into feedback. And from VFS to Z1, and then there is a ground. From VFS to Z1 there is a ground, and from V naught S to ground there is Z2. From V naught S to ground there is Z2. Are you able to understand? I just put it in this manner. Did you get it? From V0S to VFS there is Z3. From V0S to ground there is Z2. From ground to VFS there is Z1. That's it. What do you see here? What is your VFS? Here your VFS is Z1 by Z1 plus Z3 into V0S. VFS by V0, that would be beta S. So beta S would be here Z1 by Z3. So actually this is the actual beta. This is just a way to remember, okay? But you need to remember this one. Remember this one. But you shouldn't be getting confused that, sir, your beta is purely, like in beta there is no frequency content, and even in the forward gain there is no frequency content. And what is the use of this Z3 then, sir? Your beta is Z1 by Z2, and what is the use of this Z3? Right? Remember this one. I will tell you one more thing now. Now this is also approximated one. Why it is approximated one? What do you think? Why it is approximated one? This is also approximated one. So why it is approximated one? What do you think? This was our VF, no? What did I do? I simply applied the voltage division. Z1 upon Z1 plus Z3 into V0. Can I apply the voltage division here? From VFS is open circuited. No. From VFS resistance R is connected. No. From VFS resistance R is connected. So you cannot write potential division like by this way, because here resistance R is connected and that is going into OpAmp, and since virtual short will be valid, so this would be 0. This node will be 0. So resistance R is connected there. So you cannot write that, okay, like I can write Z1 upon Z1 plus Z3. That is also approximated one. Okay, this beta value is also approximated one. So what do you generally do? I will just tell you the derivation. I will not derive it here. Okay, no one is going to derive it. No one will ask you as well. Even in the ESE written test, even in the ESE mains examination, they will not ask you the derivation of this one. That is my guarantee. Okay, so what do we generally do is that we take the finite output resistance here. We take the finite output resistance of OpAmp. Then we find this node, and from here we find the feedback factor beta, and then we get some particular expression. Here we will take the finite output resistance, then we find this V0, and from V0 to VF we find the feedback factor. Okay, so all the expression Z1, Z2, Z3 all will come into action. So based on that you get your final expression. From there we come to the conclusion that your beta will be something like this. After that the conclusion is this. So I am also not telling you to mug up the conclusion. I have also given you a way to remember the conclusion. What is the way? Way is this. That's it. So till now in this lecture, this is the important thing for you. That how will you write the value of beta? What is the value of beta? 0 minus VFS divided by Z1S plus 0 minus V0S divided by Z2S is equals to 0. That's it. VF by V0 you need to calculate, beta value you will get. Nothing else. Right? So this is the way. So I am also not telling you to mug it up. I am telling you the way. Right? We will solve the question. It will be more clear to you. And how will you find the frequency of oscillations? That, sir, okay, we have found the value of beta, but how we will find the frequency of oscillation? So that is the most important part only. So for that, what you need to do is that just copy, or I can simply copy this one only. So what you need to do, addition of all the impedance should be 0. That's it. Okay. Addition of all the impedance should be 0. Z1 plus Z2 plus Z3 should be equals to 0. From here you will get omega. From here you will get omega value. You just need to do this. No mugging up any formula, nothing like that. So we understood 3 points here. What is our forward gain? That is minus RF by R. We are getting 180 degree phase shift from here. So we need another 180 degree phase shift from this particular LC circuit. There we don't need to think anything. But just if the examiner is asking you the value of beta, then what you are going to do? If the examiner is asking you the value of beta, then what you are going to do? You are going to see here 0 minus VFS divided by Z1S, 0 minus V0S divided by Z2S. VF by V0 will be your beta, you will get to this value. And if they are asking you the frequency of oscillations, you will just go into the loop. In the loop, whatever the impedance are connected, add them up, put equals to 0. That's it. You will get the frequency of oscillations from there. Okay, you will get the omega value. Now, there are two kind of oscillators, Colpit and Hartley. Okay, Colpit and Hartley. Two kind of oscillators are there. If your Z1 and Z2, both are capacitor and Z3 is inductor, then it is known as Colpit oscillator. Colpit's oscillator. And if your Z1 and Z2 is inductor, and Z3 is capacitor, then it is known as Hartley oscillator. Hartley oscillator. How will you remember which one is Colpit, which one is Hartley? How will you remember it? Colpit, C. So majority will be capacitor. Z1, Z2 will be capacitor. What is the unit of inductance? Henry. H. If H is there, that means majority will be inductor. That's it. This is the way to remember. Hartley oscillator. Which one will be Hartley? Where there is more inductor. If there is more inductor, what does that mean? Inductor is equals to Henry. Henry means H and Hartley. And if there are more capacitor, that means CC. That means Colpit oscillator. Okay. This is the way to remember. I hope you will be able to remember it. So let's analyze our Colpit oscillator. So this will be our Colpit oscillator. Z1, Z2 are capacitors and Z3 is the inductor. So this will be our Colpit's oscillator. So let's start analyzing it. What will be the forward gain? Forward gain A. That would simply be minus RF by R. Right? And if you want to write the magnitude, that would be RF by R. And if you write down the phase shift, that is 180 degree. What will be the frequency of oscillations? For frequency of oscillation, what you will do? Find the impedance of all, add them up, put equals to 0. So what is the impedance provided by capacitor C1? That would be 1 by j omega C1. Just you need to write down all the impedance plus 1 by j omega C2 plus j omega L should be equals to 0. Right? Now what I can write? Minus j by omega, that minus j by omega, okay, no, or minus j I am taking common. I am taking common as j only. I am taking j as common. So what I will get? Minus 1 by omega C1 here, right? Minus 1 by omega C2 here. Say yes or no? Plus j omega L. J I am taking common. So plus omega L is equals to 0. Do you agree to my point? I put j as common. So 1 by j you can write minus j as well. So it will be minus 1 by omega C1 minus 1 by omega C2 plus omega equals to 0. So this j will go to this side, that will be 0 only. So what you will get here? Omega L is equals to 1 by omega 1 by C1 plus 1 by C2. So what is the value of omega you are getting? That is 1 by root L into 1 by C1 plus 1 by C2. Or you can write my omega is 1 by root L C1 C2 upon C1 plus C2. This is the formula. This is the frequency of oscillations. 1 by root L into C1 C2 upon C1 plus C2. So isn't it looking like 1 by root L and series combination of capacitor? What is the series combination of 2 C1 and C2? Series combination, that would be C1 C2 upon C1 plus C2. So 1 by root L C equivalent. 1 by root L C equivalent, where C equivalent is series combination of these two capacitors. That's it. So this is how you can remember, but I would highly recommend to do the derivation as well. It is not the derivation, it is just a way to remember. Okay, or direct you can remember as well. What will be the frequency of oscillation in case of Hartley oscillator? That would be 1 by root L series combination of C1 and C2. I generally remember it and I don't mess it up in the examination. Okay, so if you mess it up, if you think you can mess it up, you can do this thing in the examination, or if you can remember it directly, you can write the expression. And what will be your feedback factor? What will be the feedback factor? I told you how to write it down. Minus VFS into C1S minus V0S into C2S is equals to 0. So what will be your VFS by V0S? That would be C2 by C1, and minus sign is also there. So what will be the magnitude of feedback factor? That would be C2 by C1. That's it. By the way, the color is not looking that great. Yeah. So this is the feedback factor beta. Well and good. And for sustained oscillation, oscillations, what is the scene? Your A beta, mode of A beta should be greater than 1. What was your A? That was R up by R. What was your beta? C2 by C1 should be greater than 1. That's it. Right? R up by R into C2 by C1 should be greater than 1. So till now what we have studied, let's cover it up. Forward gain, R up by R providing 180 degree phase shift. For feedback factor, what we need to write? 0 minus VFS divided by Z1S plus 0 minus V0S divided by Z2S. So your feedback factor is Z1S divided by Z2S. Well and good. Am I doing any mistake here in this one? Did I do any mistake? No, nothing. Yeah, Z1S divided by Z2S. But you don't need to mug it up. You will just derive it there. Not the derivation. It is not the derivation. Just a method to remember. And for this one, for finding the frequency of oscillation, you just need to put the addition of all the impedance should be equals to 0. So here we started with Colpit oscillator. Colpit C. C means capacitor. So Z1, Z2 will be capacitor and Z3 will be inductor. So here we know the forward gain. For finding the frequency of oscillation, all the impedance should be equals to 0. 1 by j omega C1 plus 1 by j omega C2 plus j omega L should be equals to 0. So omega would be 1 by root L C equivalent, where C equivalent is series combination of C1 and C2. So what will be the series combination of C1 and C2? That will be C1 C2 upon C1 plus C2. So 1 by root L C equivalent. What will be the feedback factor? What will be the feedback factor? Feedback factor will simply be, here you can write 0 minus VFS divided by the impedance. What is impedance? 1 by C1S. So that would go upward. So G minus VFS into C1S plus 0 minus V0S into C2S is equals to 0. From there you would get to know your feedback factor is C2 by C1. And for sustained oscillations, your mode of A beta should be greater than 1. So this should be greater than 1. That's it. In the same manner, you are going to analyze the Hartley oscillator. So write down all the expression on your own. First, what you are going to write? You are going to write the forward gain. First, you are going to write the forward gain. So you can write down all the expressions on your own. So what will be my forward gain? Forward gain A. That would simply be minus R up by R. It would be the same only. Magnitude will be R up by R and angle provided would be 180 degree. No doubt about it. What about the feedback factor or frequency of oscillations? Frequency of oscillations. So that would be j omega L1 plus j omega L2 plus 1 by j omega C is equals to 0. So omega L1 plus omega L2 minus 1 by omega C minus 1 by omega C is equals to 0, right? Because this would be minus j. So j will come common. Omega L1 plus omega L2 minus 1 by omega C is equals to 0. So omega square into L1 plus L2 is equals to 1 by C. Or I should write 1 by omega C, and here I am not writing omega square. Basically I took omega common, nothing else. I took omega common from here. So what will be the value of omega here? That would be 1 by root L1 plus L2 into C. That's it. This is the value of omega. And what will be the feedback factor? For feedback factor, I am just going to copy this one. Feedback factor. So these were just some standard circuit which can be asked sometime in the examination. So that's why it was important to deal it here. But these are not important in the examination. They are not expecting you to remember something that you have mucked up. So these are not that important, but still, if some date can come, then you should be aware, right? So you should have the aptitude of solving it up. So 0 minus VFS divided by L1S minus 0 minus V0S divided by L2S is equals to 0. So what is your VFS by V0S? Or you can say beta S. That would be minus L1 by L2. Minus L1 by L2. What is the magnitude of beta? That is L1 by L2. Magnitude of beta is L1 by L2. And for sustained oscillations, A beta mode of A beta should be greater than sustained oscillation mode of A beta should be equals to 1. So RF by R into L1 by L2 should be equals to 1. That's it. This is the condition for sustained oscillations. Well and good. Everything is crystal clear. So this was just some standard circuit which we covered in some 25 minutes. So I told you the method to find the value of beta, and I also told you the method to find the frequency of oscillation. So that's it about these standard circuits. Now let's solve some problems. So this is a very good problem. You need to find the frequency of sustained oscillations. What do you think? What is the value of feedback factor here? And from where you will get the forward gain? Pause the video, take your time and think of the circuit. I will give you a hint. The hint is the circuit is very simple. It is not complex. This is the hint. Okay. And from the only point is the best point of discussion is that from where you are getting the feedback. What is the feedback? What is the feedback factor? And from where you are getting the forward gain. Look, on the first glance, what is our habit? If I say this is my V0S and this is my VFS, this is our habit, no? What will be your V0S by VFS? Does that make any sense? Like, what will be your V0S by VFS? Okay, here virtual short will be valid, so this node is going to be 0, so VFS is 0. So does that make any sense? What do I mean to say is that virtual short is valid, no? So this node will be 0 only, so VFS is 0. You need to find what part of output is coming back to the input. This is what you need to find, right? So what I am going to do, this is my V0S, this is my V0S, this will be my VFS. Now I will redraw the circuit and you will be able to see it. What I mean to say. I will just redraw the circuit. What I am going to do is that I am going to put that R1 resistance here. Putting that R1 resistance here. And then connecting them up. Now can you see it? From output, complete VFS is this one, and this is the forward gain. This is the forward gain. and this is the feedback. So in the oscillator questions, in the question of oscillators, the important part is always to find the feedback and the forward gain. So from here to here, this is my forward gain and this part is being fed. That's it. So what is my feedback factor beta? That is equals to 1. Right? What is the phase shift divided by beta? That is equals to 0 degree. So how much you need as phase shift from here? This is required. 0 degree is required because you from the feedback path there is 0 degree phase shift. So from the forward path you required 0 degree phase shift. This is required. This is required. So what is the forward gain now? You can write V naught as by VFS. You need to find basically from here to here you need to find the forward gain. So what is the forward gain? From here to here what will be the gain? Simply apply like what this will be. This node will be 0. So what this value will be? That value will simply be minus 1 by R2 C2. Right? Now if this is my minus 1 by R1 C2. What you are doing, you are applying nodal here. 0 minus, you can say it x, and this is your final output. Let's just say V naught dash. So your target is to find V naught dash by x. So 0 minus x by R1 plus 0 minus V naught dash by 1 by C2s is equals to 0. So from there you get to know this node is minus 1 by s into R1 C2. Say yes or no. Right? Now what this node will be? This node will be, again minus sign would come, so minus minus would become positive. 1 by s R1 C2 into R2 C2. R1 C2 R2 C2. R1 C2 R2 C2. Okay. R1 C2 R2 C2. And how much gain this will provide? Minus 1. So what this node will be? This node will simply be, and any input you can assume this is x. So this will be x here into x, and this node will simply be minus 1 by s R1 s square will be here, right? S square will be there. So another frequency component will come. You just need to find the forward gain. This should be easy for you. Minus 1 by R1 C2, minus 1 by S R1 C2 from the first stage. Then from the next stage, minus 1 by R2 C2, minus 1 by S into R2 C2. So from the next stage, it would be 1 by S square R1 C2 R2 C2, and from the third stage you will get minus 1. So it would be minus 1 by S square R1 R2 C2 square. Basically this is the final answer. That is equals to V naught x. So what is the forward gain? Forward gain E, that is minus 1 by S square R1 R2 C2 square. Actually I wanted to write C1 C2, but forget it. C2 square. This is your forward gain. Well and good, no doubt about it. Forward gain, what is the magnitude? And yeah, it feels like that this is providing you 180 degree phase shift, but is that so? Nah, it is not that so. Why is it so? Because S square will be minus omega square, right? S square will be minus omega square. So how much phase shift it is providing you? 1 by omega square R1 R2 C2 square. This is 0 degree phase shift only, because R1 R2 C2 and omega all values will be positive only. So this is 0 degree phase shift. Are you getting this point? Forward gain A is minus 1 by S square R1 R2 C2 whole square. But it feels like that there is a negative sign, so it is providing me 180 degree phase shift. Now, if we replace S square, that is minus omega square. So 1 minus 1, this minus and minus sign is getting cancelled. So this is your forward gain. Well and good. So for sustained oscillations, what is the condition? Which condition is already fulfilled? That is, angle of A is 0 degree. But what is the other condition? That your mode of A beta should be equals to 1. So beta is already 1. So what is your mode of A? That is 1 by omega square R1 R2 C2 square. That should be equals to 1. So what is the value of omega you will get? 1 by root R1 R2 into C2. Better I should write 1 by C2 into root R1 R2. This is the frequency of oscillations. So this was an easy question. Just the task was to find the feedback factor. So feedback was this one. Feedback factor was 1, and forward gain was 1 by S square R1 R2 C2 whole square. That's it. Minus 1 by S square R1 R2 C2 whole square. This was the forward gain. Then we find the magnitude. This was the magnitude, and it was giving us 0 degree phase shift. What is the other condition? That mode of beta should be equal to 1. From there we find the frequency of oscillation. That's it. Very easy question. Right? Let's solve one more problem. This problem you need to solve. You need to find the frequency of oscillations and find the ratio of RF by R for sustained oscillations. Here you can directly see what is the feedback, what is the forward gain. From here to here, this is the forward gain, right? From here to here, this is the forward gain. And from here to here, this is the feedback. So this node will be your VFS, right? Because this part, like from here to here, this is the feedback, or if this node is the same, this node will be the same only, no? This VFS will be going here completely. Now in the forward path, how much phase shift you are getting? 0 degree phase shift. Angle is 0 degree. So in the feedback path, what do you need? Required solution we are doing. So what is required? Required is your phase shift should be 0 degree. This is what you need required. Without deriving the expression, can you tell me when the phase shift will be 0 degree? If the impedance provided by them, if the impedance provided by these two is infinity, parallel combination of these two is infinity, then what will happen? This will become purely resistive, no? VFS will be value will be 1 by 2 only. If the impedance provided by these two is infinity, then what will happen? This will become purely resistive only. So VFS by V naught S will simply be 1 by 2. VFS by V naught S, if simply that is 1 by 2, then if that is 1 by 2, then what is the phase shift? Phase shift is 0 degree. That's it. So for getting this thing, what is the required condition? The required condition is the phase shift provided by both of them. If they are infinity, if these two are infinity, if this is open circuited, then there is no issue. Beta will be simply some positive value. That's it. There will be no frequency content in the beta. So I just need to put this equals to infinity. So what can I do? How this will be infinity? What do I need to do? Ls parallel with 1 by Cs. This should be equals to infinity. So Ls into 1 by Cs divided by Ls plus 1 by Cs. This should go to infinity, or you can say 1 by 0. So basically this denominator should go to 0. So Ls plus 1 by Cs should go to 0. For that, Ls plus 1 by Cs should go to 0. So j omega L minus j by omega C should go to 0. So omega should be equals to 1 by root LC. Also you could have thought that at resonance this will be infinity only, right? At resonance, impedance provided by both of them would be infinity. This is how also you could have thought. So omega would be simply be equals to 1 by root LC. So this is 10 to the power minus 8, this is 10 to the power minus 2. 10 to the power minus 8, 10 to the power minus 2, so 10 to the power minus 10, 10 to the power 5. 10 to the power 5 you are getting. So if you put the values, ten to the power minus 8, 10 to the power minus 2, 10 to the power 5 radian per sec. This is the frequency of oscillations. This was the first answer. Okay, and what is the ratio of RF by R? So if this is the frequency of oscillation, so what is the value of beta now? Beta will be R upon R plus R, right? What will be the scene? The scene will be this. This was your V naught S. This will be your VFS. This is R. This is R. This is your V naught S, and this particular node will be VFS. So VFS will be half of V naught S. Basically your beta is 1/2. Here you can see angle is 0 degree. So phase shift provided by beta is also 0 degree. Now what is the other condition for sustained oscillations? That your A beta should be equals to 1. So your, what is your A? A was 1 plus RF by R, right? A was 1 plus RF by R. This is the forward gain from here to here. This is the forward gain, that is 1 plus RF by R. 1 plus RF by R. And what is the value of beta? That is 1/2. That should be equals to 1. What should be the value of RF by R? RF by R should be equals to 1. So you needed to find the ratio of RF by R. That should be equals to 1 for sustained oscillations. Everything is crystal clear or not? This is the feedback path, this is the forward path. In the forward path, the gain is 1 plus RF by R, phase shift is 0 degree. In the feedback path, the phase shift you need 0 degree, so you would put these impedance equals to infinity. For that, this will be the frequency of oscillations. Feedback factor will be 1/2. So A will be 1 plus RF by R, that should be equals to 2. So RF by R should be equals to 1. That's it. Okay. Now the time is left. So let's see one more question. Okay. I framed this question on my own. So I will write down the question. I will write it down and then we will solve it. So we can see one more question. Yeah, so this is the question. The forward gain is written as this circuitry is given. So for sustained oscillation, you need to find the magnitude of A and the frequency at which the circuit oscillates, right? Now the phase shift provided by the, which is the forward gain? This is the forward one, forward. And this will be the feedback, right? This is the feedback. This is the forward gain, this is the feedback. So in the forward gain, how much phase shift is there? 90 degree. How much do you need in the feedback? You can say, sir, 270 degree or minus 90 degree. So what is the angle provided by the feedback path you require? Beta should be minus 90 degree. This is required because in the forward path you are having 90 degree phase shift. Then in the feedback you would need another minus 90 degree phase shift, so it becomes 0. So let's try finding the transfer function. You can do it on your own. Not the transfer function, we just need to find the feedback factor beta. This is our target now. This is your V naught S and this will be your VFS. So I am keeping it up to you. You can find it VFS by V naught S, because these kind of questions we have already solved. CR circuit we have seen, RC circuit we have seen. So these kind of things we have already solved. So you should find VFS by V naught S, which I have already written. That would be VFS by V naught S. So VFS by V naught S. That would be 1 by S square C square R square plus 3 RCS plus 1. This is what we will get. Okay. So you can find it on your own. This I am keeping it up to you. You should do the calculation on your own. What will be your beta? That would be 1 by minus omega square R square C square plus 3j omega RC plus 1. Right? Now how much phase shift do you need? 90 degree. You need 90 degree phase shift. Sorry, minus 90 degree phase shift. From here, this is your requirement. You need minus 90 degree phase shift. If I put this part and this part, 1 minus omega square R square, 1 minus omega square R square C square. If I put that equals to 0, then what will happen? What you will have? 1 by 3j omega RC. Beta value will be equals to 1 by 3j omega RC. If I put this equals to 0, then how much phase shift will be there? Minus 90 degree, right? The phase shift will be minus 90 degree. And this is what it was required. For getting angle of beta equals to minus 90 degree, I am putting 1 minus omega square R square C square equals to 0. From there, I will get the frequency of oscillations as well. This was my target, that always it's not that you should be getting 0 degree phase shift or 180 degree phase shift as well. Sometimes they can just make a block diagram and they can say that it is providing you 90 degree phase shift. Then another minus 90 you will be requiring. This option they can also frame. Because most of the time students just mug it up that from the feedback path you would either need 0 or 180 degree. This is not the thing. Based on the complete loop you need to find. If you are getting 90 degree from the forward, from the feedback you would need minus 90, right? So for getting minus 90, for beta equals to minus 90 degree, what you need to do, 1 minus omega square r square c square should be equals to 0. So what will be your omega? That would be 1 by rc. This is your frequency of oscillations, right? Now let's find the value of beta at 1 by omega rc. What is the value of beta at 1 by omega rc? That would simply be 1 by 3j. Omega is 1 by rc. Omega is simply 1 by rc into rc. That would be minus j by 3. So angle provided by the beta is minus 90 degree. So requirement is fulfilled, right? So what is your mode of beta? That is 1 by 3. For sustained oscillation, what is the other condition? The other condition is mode of A beta should be equals to 1. Mode of A should be equals to 3. So this was also asked. Find the magnitude of A, that is equals to 3. That's it. These two were the questions that were answered. Well and good. So these kind of questions can come in your examination. I hope the concept of oscillations is crystal clear to you. If you find it helpful, you can like this video and share it with your friends. Okay then, thank you.